you guys have shown that you're pretty good at adding polynomials. You've shown at the board yesterday as well as today that you're pretty good. I think it's good news that subtracting polynomials is not that much different. Let me explain what we do here. With adding polynomials, with a situation like this, if it were addition, what you would do is simply drop the parentheses and add your like terms. Subtracting is similar. The only difference is this. When you drop your parentheses, you need to be able to handle that minus sign, the minus sign that's right here. What do you think you do? Any intuition on this? You know, any thoughts? Yeah, Joel.
Would you, actually, I don't know.
Okay, Braden, I'll let you take a shot at it. What do you think you do?
So I think you do 3y squared minus 2y squared, which will equal y squared.
Okay.
And then you do negative 4y minus y, or minus negative y.
Right.
Which equals negative 5y.
No.
Or no, negative 3y.
Yeah.
Yeah, negative 3y, and then you do negative 6 minus 9, and you get negative 15.
And you're doing it right. Yeah, you're doing it right. But I'm wondering if we could like organize a little bit better as far as like.
Oh,
you're.
vertical.
Say again.
Organize it by subtracting it vertically.
You could do that. You definitely could do that. But we could do it horizontally too. What do you think, Ben?
Do you have to like distribute the negative sign?
That's the word that I would use, and that's really what Braden was doing, right? He was like distributing that minus to each of the terms. So I would think of it like this. I would distribute this minus sign to the first, second, and third terms. And so at that point, once I've distributed, now I can drop the parentheses. So it would look like this. 3y squared minus 4y minus 6. So that first polynomial remains completely unchanged. The second polynomial should have all the signs changed because you just distributed that minus sign. So it looks like this. Minus 2y squared plus y minus 9. Once you've done that, we want to collect our like terms, and Braden was kind of doing that verbally. Collect the like terms and combine them. So let me ask you guys, what term is like 3y squared?
Negative 2y squared.
Negative 2y squared, I agree. So what is 3y squared combined or added to negative 2y squared?
Y squared.
Just a 1y squared, I agree. So then we continue on and we ask ourselves, what is like negative 4y?
Wait, why is it plus y? Why? So it's negative 4 plus...
No, it's not. I don't know. It's negative.
Negative 4y plus 1y?
Negative 3.
No, you regular 4y.
I don't know.
No.
Negative 3
Come on.
We're, Matt,
Think before you say.
we're adding. So negative 4 plus 1 means left 4, right 1. We're still in the negatives. So it'd be negative 3.
So negative 6 plus negative 9 is negative 15.
And that's what you said as well. So that is correct. So a second ago, Braden, I heard you say something along the lines of why is it plus y? And I think Andrew kind of helped you out or something. You got it figured out? Because when you subtract a negative, you're really distributing that minus sign, turning it into a positive. Okay, any follow-up questions before you try one by yourselves? Okay, so why don't you try number 8? Well, shoot, you know what? Let's do number 8. Let's do number 8 together, and then I got another one for you guys to try by yourselves.
They're different.
This one says subtract vertically. Sorry, I didn't read the directions.
It's the same thing.
It's the exact same concept, but I want to point something out. I think this is worth the attention for us here. We're going to distribute again. Yeah. So what we're going to do is still distribute the minus sign. Still distribute the minus sign, changing all the signs in that second polynomial. But then we'll write it vertically. Kind of an interesting thing happens. If I were to write 3y cubed minus 10y, and then if I try to line things up, watch what happens. It would be minus y cubed, right? And then plus 9y squared. Do you see how when I write it as I currently have, do you see how the correct degrees are not lined up?
Well, that's why you have to line them up.
So we are going to line them up. What I'm going to do is I'm going to take this minus 10y, and I'm going to move it over here. What could I put in place of where that used to be?
0y squared.
Plus 0y squared. That's right. So I'll just use that as a placeholder. So it'd be plus 0y squared right there, keeping everything vertically lined up. You don't really have to put that in there, but it gives you a little placeholder so that you can keep things straight, which is kind of the point of vertical subtraction. Then finally you'd have minus y. Something important for you guys to note, we had a little discussion about this in our other class. Once you have done that, you've lined everything up vertically, you've distributed the minus sign, we're actually going to add the like terms. We're just going to continue to add vertically like we did before. So when I attempt to combine these, what do you think we get?
No,
Y.
no.
2y
to the third.
cubed.
2y cubed, or 2y to the third. Agreed. when I attempt to add these.
9y squared.
Yep, 9y squared is correct. And then how about the last column?
11.
No,
Negative 9.
no.
Negative
Negative
11.
9y.
Negative 11y. There you go.
Oh,
Negative
that's what
11.
I said. He said that.
He said 11. I might not have heard you. Okay, questions? Spence, you just said what?
I'm just confused.
Can you explain where you're confused?
Where did you get the y squared?
The 0y squared? So what do you think 0y squared is overall?
0.
Isn't it 0?
Yeah.
So what I did, I put that in there. I artificially put that in there simply to hold that place value. If you look at the first polynomial there is not a y squared term, which causes my columns to get all messed up. Things wouldn't be lined up. And so I put that in there simply to make sure that things stay lined up. So adding 0y squared is like adding 0. So it didn't really change anything. It just changes the form, so it makes it easier to line up. Go ahead.
Well, in adding polynomials, we didn't distribute the plus sign.
We did, technically. When you multiply by +1, does that really change anything?
No.
It does
I
not.
was saying in adding.
Yeah. You said we didn't distribute the plus sign. So what I'm questioning is, what effect would that have?
It could change the negatives to positives.
No, because a positive times a negative is still a negative. And a positive times a positive is a positive. So, that make sense? Technically, we were doing that. It just doesn't show any change.
Okay, and then another question. Up here, I didn't distribute the minus sign, but I still got the same answer, just by subtracting the
Well, that's what
negatives. Yeah.
it really is. Like you were telling it, you're like saying out loud what you were doing. You really were distributing the minus sign because you're like minus negative y is really plus y. You were distributing it.
Yeah, and then down here, I didn't distribute, but I changed my answer to minus 9y squared.
You definitely want to distribute.
But
Like-
up here, didn't change my answer, but down here did.
So you weren't being consistent one way or the other. So you must have made like a small error.
No, because look.
Okay.
Because right here, if you're subtracting.
This horizontally, we could do it vertically, but whether we do it horizontally or vertically, we need to distribute that minus sign like we did before. So this minus sign gets distributed here, there, and there, leaving us with this. 3d squared plus 5d minus 9 minus 12d squared plus 6d minus 11. So distribute the minus sign into that second set of parentheses, and now add your like terms. So my like terms look like this. 3d squared is like negative 12d squared. So you should get negative 9d squared. All right? And then we have other like terms, like the 5d with the 6d. That gives us plus 11d. And then our final pair of like terms is negative 9 with negative 11. When you add those up, you get negative 20. That would be your final answer, final simplification. What do you guys think? It's a lot of good answers.
I think I'm gonna cry.
Question, yeah.
Let me use a calculator and add all the like terms.
Once you've distributed the minus sign, then you add all the like terms. Yep. So let me ask you guys a couple of questions. What's the name of that polynomial?
Oh, wait.
Negative
Trinomial.
Trinomial. What is the degree?
Negative 9. The coefficient.
2. Lead coefficient?
Negative 9.
Negative 9. Good deal. All right, good review. Hey, let's go back to the board today. Just kind of lay some groundwork for upcoming days. So, here we go. I want you to notice some things about numbers 1 and 2, just some subtle symbols. And Peyton, this was one of the reasons I was kind of talking with you about some of the symbols, like not having the plus signs. I want you to compare let's look at number 2 specifically. Number 2 specifically. Notice how, please, number 2, doesn't it look a lot like what we've been doing?
Yeah.
But what's missing?
The thing in the middle.
Which means multiplication.
Minus signs, plus signs. Yeah, there are no plus signs in between. There's no minus signs in between. Hey, so if you have parentheses that just sort of back up against each other, what does that mean? It means multiplication specifically. And so it's really important that we understand that so that we look at something like that and think, oh, that's addition, because it's not. It's multiplication. Let's go back to number 1. I'm wondering if your instincts will serve you well. Let's see what you think here. If we're multiplying two monomials together, like negative 9t to the 7th times negative 5t to the 4th, I'm wondering what you think. We got to handle the number bases and the variable bases just a little differently. Haley, do you have an idea about what you'd want to do with either of those? Number one, yeah. I'm not looking for you to complete it. I'm just wondering, like, how do you think you'd handle the -9 and the -5? Because those are like similar things, as well as the t to the 7th and t to the 4th. Wondering if one of those two you're comfortable with.
Multiplying 7 to the 4.
Okay, so how do you think that would go? If we've got t to the 7th times t to the 4th, what do you think we'd be doing there? Like, how would that work out?
Right here. Yeah.
We have to distribute the negative 9 to the 7.
Right here.
It's 11.
No.
Yeah, you add the 20. Ben said. Come on,
No, don't you multiply?
It's got 28. Yeah.
She says that.
I don't think it's that.
I think that's right.
Multiply.
The numbers you mean?
45 t to the 11.
Are those the bases? The
That's right.
negative
That's
nine?
right.
Would
Well-
they be a base or would they just be the coefficient?
Tell you what, they're coefficients. They're coefficients. Hey guys, there's enough discussion. I think there's maybe enough confusion. Let's look at it like this. Let me explain how can I explain? Thank you. If you guys remember, multiplication is commutative. In other words, the order does not matter. And so I'm going to choose to multiply the -9 times the -5 first. I think that's the more familiar thing. What's 9 times 5? And a negative times a negative? Positive. So we'd start off with 45. And then it comes down to the question of, did Haley handle the t's right? So we've got t to the 7th times t to the 4th. When you are multiplying bases that have exponents, what do you do with the exponents? You add them. You're right, Haley. So this would be 45t to the 11th. 45t to the 11th. That makes sense? Okay?
It does.
Let's see how you guys can handle number 2. Number 2 is obviously somewhat more complicated, but it's similar enough you probably can do it. I'll give you a couple of moments to try that
I see it.
using the same principles we just did. Had a couple questions. Hey guys. I'd like to hear from a few of you what you did here. How did you guys handle the 6 and the -6? Those numerical bases are pretty unique here. It's -36. You just multiply those numerical bases as you always have. Nothing too new there. Then what I've got is I've got some C's and D's. Haley H. With the C's, if I think about multiplying the C squared times the C squared times the C, what do you think that is? C to the 5th is correct. And then finally we've got the D's. D to the 3rd, D to the 3rd, and then times D. Aaron, what do you think about that?
Yeah, that's what I got.
D to the 7th is correct. And that would be your correct final answer for that one right there. See you guys on Thursday. We'll keep working with multiplication then.
Right here. Ready? Last one.